Okay, this will be video number 2 for quiz number 3. Video number 1 stopped recording on me. I'm not really sure why, but we got to the point where we know that we have to get power to J63 right here, boiler enable LCI, and once we do, we know that the pump is running because the flow switch is made. We know that the dampers are open. We know that the blower is running because up here our airflow switch is made. So we know it's ready to go. And right here we've got J5, 2, 3, and 4. And if we follow those down, this will finish up page 1 of the wiring diagram. Comes down here, and we've got our main and auxiliary gas valve. I think I showed you with the gas valves and which one had the proof of closure that it's actually 2 gas valves built on the same body, but there are 2 separate actuators, so you have to power them independently. That's the main gas actuators, and here is the pilot gas solenoid valve, and here is the ignition electrode, and there is actually a page in the Bryan IOM that shows you how to adjust the ignition electrode for the right arc gap, so that you know you're getting the spark. But when you get to the point where you're ready to open the pilot gas valve, turn on the ignition electrodes, make the spark, get the pilot lit, turn on energize the main gas valves, light comes on here, you know the gas valves are open, the boiler is ready to fire. So getting through all the safeties, getting to this boiler enable, that should get you into the sequence where it goes into the ignition startup. So that pretty much finishes up page 1. So let's go back here and look at diagram page 2. And we've looked at a little bit of this already, but here is where we had our enable relay. I wanted to explain a little bit about these temperature sensors right here on, this is J8, terminal 4 and terminal 5 right here. That comes over to the inlet sensor, water inlet sensor. That would be the return water temperature, water coming into the boiler. And you can see it's a 2-wire sensor. And then skip down here to 8, 9, 10 on J8, and you see that's the water outlet temperature sensor. You see it's a 3-wire sensor. Why 2-wire for the inlet, 3-wire for the outlet? Well, Honeywell, I won't say just Honeywell, but the manufacturer of this particular sensor makes this sensor with 3 wires because it's a dual sensor. It is a safety sensor. Inside of it, it has the normal thermistor that measures the temperature, but then also has a safety so that if the temperature overheats, it will shut the boiler down. And it's made that way because you really have to have a high limit temperature control. And when you're just using these thermistors for temperature sensors, you don't necessarily have a separate safety control. So in order to meet that code, they use this 3-wire sensor that has a safety circuit in it that will shut the boiler down if that safety circuit opens at a certain set temperature. And that's why it's a 3-wire sensor. So let's take a look here. I want to go to the R7910 Sola Honeywell information here. I wanted to go down to this page right here where it says required components, and here it says dual element sensor contains sensor plus limit 10k ohms, beta equals 3950. I don't know what the beta equals 3950 means, but I do know it's 10,000 ohms. And typically when you're looking at a thermistor, and this one is a dual element sensor, when they say 10k ohms, 10,000 ohms, typically that's a 10,000 ohm at 77 degrees Fahrenheit, or 10,000 ohms at 25 degrees centigrade, because 77 degrees Fahrenheit, 25 degrees centigrade is the exact same temperature. Real quick, if I highlight this, and I'm doing this on the PDF that you're looking at, or you have access to. I highlight that and I right click, search on Google, and here the first one that comes up, it says parts cleaverbrooks.com thermistor temperature sensor for Falcon Honeywell. So I click on that, and here is the sensor. It is a 3-wire sensor. It's used for a Cleaver Brooks Falcon, but it's got a Honeywell part number. Well, Cleaver Brooks uses this same Honeywell Sola controller on a lot of their boilers, and they call it the Falcon. That's their trade name for this controller. So let's say that you're working on a Bryan Triple Flex boiler, and you need to get one of these temperature sensors because you have one that has failed. Could you go to a Cleaver Brooks distributor or somebody that sells Cleaver Brooks boilers and get this? Absolutely. This is the exact same sensor that Cleaver Brooks uses for their boilers, that they use the Falcon controller, which is the exact same Honeywell controller that Bryan uses on the Triple Flex. So the nice thing about that is that once you worked on a Bryan Triple Flex boiler and you got familiar with this controller and you know the wiring, you've got all the details down on how it's wired and understand that. If you went to a Cleaver Brooks boiler that had the Falcon system on it, it would look exactly the same, and you would already know a lot about it before you even started working on it because you worked on something similar to that. So it makes it nice. But that is the dual element sensor. Here is the single element sensor, different part number. So you'd want to make sure that if you had to replace the sensor, you get the right part number, the dual element 3-wire or the single element 2-wire. And if you scroll down a little bit here is a chart, and I'll probably put some of this on the quiz because I think it's important that you are able to go to a temperature resistance chart here and look at a couple things. First thing I want you to notice, it says NTC, and for the third year apprentices, because we went over a Copeland compressor module in an earlier class, you know what NTC stands for, but second year you may not. It's a negative temperature coefficient. I'll put that on a quiz. NTC is negative temperature coefficient sensor. And here is a chart that tells you temperature versus resistance. What a thermistor is, it's a device that measures the temperature by changing resistance. And when you look at this, here is the lowest possible temperature, minus 30 degrees centigrade or minus 22 degrees Fahrenheit. Here's the resistance. It is 171,000 ohms. So the lowest temperature, highest resistance. You get down here, this is the highest temperature, 248 degrees Fahrenheit, 120 degrees Celsius or centigrade. And it is 0.56 K, which is actually 560 ohms. Or here on the 10K, it's 39 or 390 ohms because all these values are in 1,000 or K ohms, 1,000 ohms. So as the temperature goes up, the resistance goes down. That is what negative temperature coefficient means. So when I said that it's a 10,000 ohm thermistor, here is 10,000 ohms, 10.00 K, which would be 10,000. That is at 77 degrees Fahrenheit or 25 degrees Celsius. That is a very standard 10K thermistor. It is 10,000 ohms at 77 degrees Fahrenheit. 77 degrees Fahrenheit is 25 degrees Celsius. If the temperature is going up, here's 77, 104, 140, 176. Here the resistance is going from 10,000 ohms to 5,320 ohms to 1,750 ohms. So that is a negative temperature coefficient sensor. Back to the page here. There's your 2-wire sensor. Here's your 3-wire safety sensor. There is a remote input here. I'm really not going to spend a whole lot of time on that other than to say that for people with building automation inputs, you want to send a signal to this boiler for remote set point, or you want to modulate the boiler from a remote set point, that's where you would do that. If you're going to have multiple boilers, maybe you want to have an outdoor temperature sensor or a header temperature sensor. Maybe you're using this same heating boiler to heat up domestic hot water. Here is a way of using a temperature sensor in your domestic hot water system to heat the domestic hot water off of this same boiler. The last thing here's stack sensor. That would be for your flue gas stack. I guess the boiler does have that. Obviously, it shows it there, so you can actually look at the stack temperature, and it is another safety type. You can see that both the outlet water temperature in the stack and also the domestic here, those are the safety type 3-wire thermistors. And then here you have a remote reset button, and if you remember, because of the dashed lines right here, this reset button would actually be right on the front face. On the Sola controller, there is a reset button on the controller itself, but you also have this remote reset button up on the front panel. Everything else on page 2 has to do with communication. Modbus, I'm sure that's a term you'll be hearing in the future, or if you haven't already. Anytime you're talking about machine language, and that goes more to industrial automation stuff. Modbus is very common. The classes that I've taken, and one of the classes that I teach at Columbus State, we talk about manufacturing engineering, and most all manufacturing engineering equipment is tied together, and Modbus is the communications protocol that they use. It's very common, but here they're showing how you can use a building management system, and you can have multiple boilers, and you have your Modbus communications with your input-output card, and here it shows you how to wire a Cat5 cable. If you've ever seen a Cat5 cable, yeah, it's got 8 conductors, and there's orange, green, blue, brown, and there's white stripes. So you can. This boiler does have communications that you can connect more than one boiler to a master controller.